Hello friends, now we will take the problem of centroid based on C section which is given in the problem. So in this video, we would be locating the centroid for a C section. Let's read what is given in the question. The question is, locate the position of centroid for a channel section as shown in figure. Here the diagram is given. As we can see here, a C section, or in other words it is also called as channel section, it's given. The dimensions of the channel section are given. The question is to find the position of centroid. And when we say position of centroid, it means we need to calculate x bar and we need to calculate y bar. So in order to get the centroid for the C section, the first thing is we would be dividing this C section into three rectangles as I have divided here. Here I have divided it into first, second and third rectangles. Now after this, let us start with the solution part. Here I'll say that since area 1 indicates area of first rectangle, as we see the first rectangle is here, it will be having the dimensions. Since this width of the rectangle from, we can say, at this region till here it is given as 1000, and from 1000 if I subtract 200, that is the width of the web given here. So 1000 minus 200 will give me 800. So this much portion from here till here for the first rectangle, it is 800. So I'll draw the first rectangle. So here we are having a rectangle of width 800 mm and height is 200 mm. The first rectangle, so area will be 800 multiplied by 200, that comes out to be 16 into 10 raised to 4 mm square. After getting area, here I will calculate x1. x1 is nothing but the location of y-axis for first rectangle. Here if we have the rectangle number 1, its y-axis will be passing exactly at half of 800. So this distance is 400 mm. So it is 400 from, we can say, if I can show you in the diagram, it is 400 from this distance where we have separated the rectangle. But as we know, in case of centroid, we are taking the reference as x and y axis. So I have to measure the distance from y axis. So from y axis, this will be 200 plus 400, because here we are having at 400 the y axis for the first rectangle. So that becomes 200 plus 400, which gives me 600. Now after getting a1 and x1, now I will find y1. y1 is the location of x-axis for the first rectangle. X-axis for the first rectangle, it would be located at, since we are measuring the distances from x and y, here my reference would be x-axis. So from x-axis, I'll take the distance. First rectangle is starting after 200 plus 1600. So it is 200 plus 1600 mm plus the x-axis for rectangle number 1, it will be at half of 200. So it is 100. So y1 will be 1900 mm. Now after getting these values, that is a1, x1 and y1, similarly I will calculate a2, x2 and y2. For that I will draw the second rectangle. Now this second rectangle is having width 200 and its height is 200 plus 1600 plus 200, that is 2000. So it is 200 by 2000. This is the second rectangle. Its area will be 200 into 2000. That gives me 4 into 10 raised to 5 mm square. Next, x2 will be equal to, x2 is the location of y-axis for second rectangle, and since we are measuring the distances from x and y, here I'll say that y-axis of the second rectangle would be exactly at half of 200 if we measure it from y-axis. So x2 is equal to 200 divided by 2, that is 100 mm. Then y2 represents the x-axis of second rectangle, that will be exactly at half of the total height. So as we can see here, rectangle number 2 is having its height as 2000, so its x-axis will be exactly at half of 2000 from x-axis, so it is 2000 divided by 2, so that is 1000 mm. Now once we have a2, x2, y2 also, I will also calculate a3, x3 and y3. Now since rectangle 1, rectangle 3, they are having same area, so here I will draw rectangle number 3. The width of rectangle 3 is 800 mm and its height is 200 mm. This is the rectangle number 3 having the same dimension as rectangle 1. So therefore area 3 is equal to 800 into 200, 16 into 10 raised to 4 mm square. x3 is the location of y-axis for third rectangle. Again this y-axis will be at half of 800, that is 400 mm. And if we take the distance from the origin, then it will be 400 plus 200, that is 600 mm. y3 will be the location of x-axis for the third rectangle, and this x-axis will be at half of 200, that is 100 mm, because if we look into the diagram for this C section, rectangle number 3 is lying on x-axis. So if I take the x-axis for the third rectangle, its distance from the x-axis will be half of 200. Now after getting all these values, we can easily go to find x bar and y bar. I'll say that since location of centroid with respect to y-axis is given by x bar is equal to a1x1 plus a2x2 plus a3x3 upon a1 plus a2 plus a3. Now we have to put all the values here that I'll write on the next page. So therefore x bar will be equal to a1, the value is 16 into 10 raised to 4 into x1, it is a1 x1, so x1 is 600 plus a2 x2, a2 is 4 into 10 raised to 5 x2 is 100 plus a3 is 16 into 10 raised to 4, x3 is 600 divided by area 1 plus area 2 plus area 3. So from this, if I calculate, I will be getting the x bar value as, it comes out to be 322.22 mm. This is our first answer. Similarly, location of centroid with respect to x-axis is given by y bar is equal to a1y1 plus a2y2 plus a3y3 divided by a1 plus a2 plus a3. So here I'll put the values on the next page. Therefore, y bar is equal to a1y1, and the value of a1y1 is, a1 is 16 into 10 raised to 4, y1 is 1900 plus a2y2, a2 is 4 into 10 raised to 5, y2 is 1000 plus a3y3, a3 is 16 into 10 raised to 4, y3 is 100 divided by area 1 plus area 2 plus area 3. So from this, if I calculate, y bar value comes out to be 1000 mm. This is the second answer. Once we have got x bar and y bar, we can easily show it onto the diagram. So here I would be marking the centroid on the C section given. Now x bar value is 322.22 mm and x bar is the distance with respect to y axis. So first I'll keep this C section onto the x and y system. So the y axis is at 322 and x axis, it would be at a distance of 1000 mm. So exactly at half, and this intersection will give the centroid, that is the intersection of x and y axis. And once we have located the centroid, we can easily say that the problem is over, and hence we have completed the location of centroid for the C section.